All right, I think we are ready to start our next event now, so feel free to wander over and settle in. My name is Rachel. I'm a researcher at Woodwell Climate Research Centre, and I'm really happy to welcome you to the Cryosphere Pavilion here. And of course, I'd like to welcome all of you here in person, and also all of you at our Cryosphere hubs in Stockholm and in Geneva, and of course, all of you who are watching on the live stream as well. And those of you joining virtually, do feel free to put your questions in the chat as we go along, and we can come back to some of those at the end. So we've got a fantastic event now looking at peatland restoration, of course, a super important tool for climate mitigation. And I'm going to hand it over now to our first speaker, Gustaf Hugelius from Stockholm University. Thank you.
Thank you very much, Rachel. So I'm the first talk in this session on peatland restoration. I'm going to talk about northern peatlands in a very general way, a little bit about the potential for restoration as it relates to the current extent of drainage in northern peatlands, but also talk about the map products we have available to us to actually study northern peatlands. And then I'm also going to try to compare a little bit the greenhouse gas emissions that come from drained or damaged peatlands that are potential restoration targets, and compare that to the damage or the impact to the peatland greenhouse gas balance from permafrost thaw. So I actually want to start with a slide where we go through the definitions of wetlands and peatlands. Definitions can seem boring, but they're actually super important, especially, to any science or policy it's important, but it's especially important when you try to make maps of something. In my scientific work, I do a lot of map making, and if I don't have a very precise definition of what I'm mapping, things will actually become mixed up a little bit, and different sources might have different definitions. So there are a lot of different definitions of both wetlands and peatlands. Here I've chosen two quite common ones that also correlate to what I have been working with in the papers that we will be presenting later. So wetlands, this is by the US definition, are saturated with water long enough to promote wetland processes. So this is really an ecological definition, if you will. It refers to areas that have hydrophytic vegetation, so vegetation that's adapted to wet conditions, and soils that also really reflect the wet conditions. You have waterlogged soils that are often anoxic and so on, and these are wetland conditions. Wetlands then may be peatlands, but there are also wetlands that are not peatlands. So peatlands, they are a specific type of wetland that is characterized by having relatively thick layer of peat, that is organic soil at the soil surface. So if you have more than 40 centimeters of organic soil accumulated at the top of a wetland, then it's a peatland. Other definitions of peatland actually use 30 centimeters of peat, and there are also other, in some countries, what they still use ecological definitions of peatlands as well. So here again, there are a lot of different definitions in the global literature and between countries, which also makes sometimes comparison between countries quite difficult. This definition of 40 centimeters aligns with the international and global systems used in soil science. So for me, it's quite practical because that's also where my background is. One of the things that is interesting when it comes to the definition of peatlands, when you are working in very northern areas, in permafrost areas, is that actually when you have a peatland, when you get permafrost in it, so that the soil freezes and you have ice accumulating in the ground, the whole peat is actually lifted up by the expanding ice, and you end up with a wetland or a peatland that actually has a dry surface because the peatland lifts it up. So this image here shows two of my colleagues digging in a permafrost peatland, and as you see, the surface is actually completely dry. So these permafrost peatlands are by definition wetlands, but they are not wet. If they thaw, as climate warms, they will become wet again. But this is also a chicken and egg type problem, which makes it a little bit tricky to map this sometimes. A lot of other Arctic or permafrost wetlands, they are wet, and they look like this, for instance. This is an example of a wetland at the base of a huge permafrost cliff that is thawing in Arctic Canada. You see a person there for scale standing contemplating this wetland. This wall behind him is it's pure ice and frozen soil. It's about 30-40 meters high. And as this thaws, it creates a wetland environment with a very dynamic greenhouse gas emissions associated to it. So I wanted to give a general overview of some facts on northern peatlands to sort of frame the talk as we go on. There are a lot of different estimates, but most estimates for northern peatland carbon storage converge somewhere around 400 to 500 petagrams of carbon, which has mainly accumulated since the last glacial period. So in the last, say, 10 to 14,000 years. And this also means that these peatlands have been a sustained sink for both carbon and nitrogen, pulling carbon and nitrogen out of the ecosystems and the atmosphere into the soil, effectively cooling the climate for at least 10,000 years or more. This sink capacity, I mean, northern peatlands are still a carbon sink. They're still cooling the climate for us. But this sink capacity is really vulnerable to disturbances. And here I list human disturbances, natural disturbance regimes, and climatic disturbances, which is what I'm going to talk a little bit more at the end. Permafrost thaw in peatlands that is driven by climatic change. And human disturbances are largely drainage, erosion of peatlands, fire, a lot of different interactions that humans have with peatlands. And those we can potentially restore, right? A large portion of the northern peatlands and global peatlands have been degraded and can be restored. One thing that is quite interesting when it comes to northern peatlands is that they're super important for the global climate, for the carbon cycle, but they're still really poorly mapped. There are not any really good high-resolution dedicated peatland maps. I'm going to show you an example of a map that we published last year that is, I think, is perhaps a step in the right direction from earlier maps, but it's still not good enough for what we really need. And if you're interested in learning about northern peatlands, there's a fantastic scientific paper from Evel Gorham, published in 1991, that I think is still a landmark paper that, if you want to read up on this, if you Google Gorham 1991, you find a fantastic paper to get you started on learning more about northern peatlands. And another thing that is relevant is that there are different ways that people have studied or quantified northern peatlands. And one of those is peat inventories, which are basically tables that summarize how much peat, how much drained peat, and so on there is in each country of the world. And this is also similar to what is being reported to the UNFCCC and what is being used to sort of keep track of countries' peatlands and peatland emissions. And before we started looking at this last year, there had really never been any reconciliation between the peatland inventories and the actual physical maps that show you where the peatlands are. Because the inventories, they're just tables. They're really valuable tables, but still they're just tables. It just tells you that Russia has X square kilometers of peatland. It doesn't really tell you where in Russia. And we need to know that to sort of go to the next step in the scientific studies of this. I also want to give you a background on human alteration of peatlands. This is a very brief overview. This is, the session is about peatland restoration. The following speakers after me will talk more practically about restoration projects, and I'm more giving a general overview, but I still wanted to sort of give you some of the numbers. And as much as 15% of global peatlands, this is global now, not northern, are drained or damaged by direct human intervention. So the water level has been drained or the surface has been damaged in some way. They are hydrologically damaged. This amounts to roughly 500,000 square kilometers in the non-tropics, so that's northern and southern peatlands, and more than 0.2 million square kilometers in the tropics. Tropical peatlands and northern peatlands are very different in the dynamics and how much greenhouse gas emissions you get from them after disturbances, of course. So they're usually divided and treated separately. And it's estimated that this is actually a relatively old estimate now, so these numbers might have changed. But emissions from peatland drainage and fire are roughly 6% of human anthropogenic, or all anthropogenic emissions, and they are about a quarter of all land use emissions. So this is a really significant part of the alteration we have to the global carbon cycle and the global climate. And there's also very ample evidence that successful hydrological restoration, which means that the drained peatland, which needs to be wet to function properly, you restore the hydrology by plugging a ditch or whatever you do, you get the water back in there, and you have a wet peatland again. And that there's multiple evidence that it will reverse CO2 losses, and you need to be careful when you do a restoration project to also consider the methane dynamics, because you can have a situation where a restored peatland actually emits a lot of methane. So there's a balance there at which which also differs between different types of peatlands and so on. And I'm not going to get into the details of that now, but there are a lot of success stories out there and a lot of knowledge to build on to sort of get more momentum in peatland restoration. So I already talked about this actually, but there are these two major ways to estimate peatland areas globally. And we really need to know peatland areas very well, and we need to know how much carbon is in the peatlands. We need to be able to scale the greenhouse gases somehow to get budgets for this. And the two ways we have to do this globally right now are either soil maps, which are global maps, and that report very large uncertainties in the extent of peatlands. And the problem here is that these are maps they are mapping all soils. They are not specifically targeting just peatlands to do the best work they can on peatlands, and they are very generalized. And the other way is then peat inventories, which are national resource inventories, usually tables, no spatially explicit data, so no maps. And it's very difficult to compare these because the soil maps, they use one definition, typically 40 centimeters of peat, and they just report to fixed depth. They say that this much peat carbon you have to 1 meter, to 2 meters, to 3 meters. You can't back out of the soil map how much of it is just in the peat and how much it is in a mineral soil that's lying below the peat. So that is a very limiting factor. While a peat inventory, they are inventorying just the peat. So when you reach the contact where the organic soil, the peat ends, and you come into the mineral soil that is below, there the inventory stops. So these two data sources have different ways of approaching that. So basically, before this recent study that I'm coming to, the overlap between maps of peatlands and peat inventory estimates were unknown. Based on soil maps, we had an idea that if we look just on northern peatlands, now we had roughly 150 petagrams carbon in mid-latitude peatlands, roughly 150 petagrams carbon in permafrost region peatlands that were not frozen. So northern peatlands that were in a mosaic of the permafrost landscape but not actually frozen, and roughly 150 petagrams in peatlands that were really frozen. And then there were a lot of published estimates based on inventories saying that northern peatlands have between 400 and 500 petagrams carbon, but those inventories couldn't tell you if it was in permafrost or not, for instance. So there was a mismatch there and a lack of knowledge. So to sort of address that problem, we published a paper last year. It's a very big group. I forgot to acknowledge all of my co-authors on the first slide, but they were all on there. It's a big collaborative project where we did, I call them new within quotation marks, because we're actually using the best existing maps from different countries. We harmonized them and we merged them together. So then we made peatland extent maps for the whole northern hemisphere, north of 23 degrees latitude. So you see peatland coverage on the left, and you see the extent of permafrost in peatlands on the right. So you see there's quite a lot of these peatlands are affected by permafrost. Now I'm going back. And we actually found that the most difficult thing to map based on the sources we had was the extent of the permafrost. The maps agree relatively well on where there's peat or not, but where there's permafrost or not is more difficult. And this is partly caused by this thing that I talked about in the beginning, that permafrost peatlands are actually dry. So they are not wet, which makes them perhaps more difficult to map sometimes. So this is an oblique aerial photograph taken out of a helicopter in Russia. And you see surfaces here that look relatively similar. And I'm going to go over here. These different surfaces, they are relatively similar, and they actually have the exact same vegetation on top, but some of them are peatlands with 4 meters of frozen peat, and some of them are sandy soils with almost no carbon in it whatsoever. But for us, from a satellite image, they look exactly the same. So they are really difficult to map. And this is a problem that we're struggling with, and I think with new machine learning techniques and high-resolution satellite data, we can map them better. But doing that for the whole Arctic is a very, very intense, labor-intensive and demanding mapping exercise. But it is happening, but slowly. So if we look at these new maps, now I apologize for showing you tables. I know you're not supposed to show tables in slideshows, but I'm doing it anyway. The take-home message I want to give is that we find that with these new maps, the peat inventories really agree quite well with the regional soil maps. And we were quite happy about that the map peat inventories in the tables, which we tend to trust because they are quite good data, they show almost exactly the same amount of northern peatlands as do the regional maps. But what we do find is that the two existing global maps of peatlands, they underestimate the coverage of northern peatlands by 1 million square kilometer. So the peat map, which is quite often used, and the global database called WISE 30 seconds, they miss 1 million square kilometers of northern peatlands. So that is really crucial to be aware of that if you want to use the global map for any type of scaling. And if we sort of click all of this through, we see that we have regional, northern, and world estimates for peatland coverage. And I just want to point to here. We have 3.46 in the regional maps, and the national inventories give you 3.2 to 3.46. So it's exactly the same number, and then the global maps deviate from that. So this is encouraging, and it also, I think, I would use that to argue then that we can also build on regional or national inventories of greenhouse gas emissions and on peatland drainage and disturbance, and link that better to the map, so that we go forward with a map tool that actually lets us also see where the drained peatlands are, because we don't have that worked out yet. So the next step after making these peat maps, the maps I showed you so far just tells you where there are peatlands. We also wanted to figure out how deep they are and how much carbon they store. So we took a lot of point observations. These dots show you where we had point actual field data, about 8,000 points of peat depth and 800 points where someone has actually measured the density and the water content and the carbon content, etc., of the peat deposit. And we used machine learning techniques, so AI techniques, to try to map out the best estimate of how deep peatlands are. And we looked at the peat carbon stocks, which are very, very variable. The size of these blobs, the purple blobs, the bigger they are, the more peat carbon or the deeper the peatland is in that particular spot. But what you can see is also a lot of points that are almost exactly on top of each other have very large differences in the amount of peat that is stored there. And this, I just showed this to illustrate that there's a huge spatial variability in the peatlands. And you can, I have been standing on a peatland in the Arctic that looks exactly the same as over there. And beneath my feet, there's half a meter of peat or something like that, a very shallow peatland. And you step 1 or 2 meters to the right, and all of a sudden you have 4 or 5 meters of peat. And you can't really tell from the peat surface. So it's a very heterogeneous and difficult environment to map. But still, we pushed ahead, and with the very large uncertainty range reflecting the large variability, we upscaled peat carbon and nitrogen stocks. You see these maps now, they show total peatland carbon storage and permafrost peatland carbon storage. And we estimate the storage in northern peatlands to be roughly 415 petagrams of carbon, but the error bar on that is plus minus 150 petagrams. So it's still a very uncertain estimate. We also made maps of nitrogen and find that there's about 10 petagrams of nitrogen. So 1 petagram is the same as a gigaton or 1 billion tons. So 400 petagrams of carbon is roughly half of what's in the atmosphere right now, for context, and slightly less than all of the living vegetation on Earth. We also looked at if you take these maps and transfer them into a map or a figure that shows peat distribution by latitude, you get this graph. It shows you the latitude, so going from in the south, the border of the tropical zone, all the way up to the high Arctic. And these different lines just show peatland extent or extent of frozen peatlands, etc. But the important thing is to see there's really a peak between 60 and 70 degrees latitude. And we actually find that half of all of the peat carbon in the whole world is between 60 and 70 degrees latitude. So in the southern Arctic, in the subarctic regions in the southern Arctic is where you have most peatlands. And this actually segues into a newer map product that came out, well, I think last week or something. And this is something that we published with the Arctic Council, the working group on conservation of Arctic flora and fauna, which has a lot of projects focusing on Arctic wetlands and peatlands. And these are maps that build on the ones I showed earlier, but that also actually map mineral wetlands. So we have both the peatlands and the mineral wetlands where there's no peat. And we find there that north of 60 degrees, it's the area we mapped. We have 2.7 million square kilometers of wetlands, and 1.8 of those are peatlands. You see the extent of the wetlands in the map here, and the red line outlines the the boundary of the working group area, the CAF working group, so the Biodiversity Conservation Working Group of the Arctic Council. That is their area of interest. Unfortunately, we didn't have map products that could align exactly to their area of interest, so we're missing products for some parts, especially in the US. Another interesting thing that came out of this map is that we combined it with a new inventory of protected areas in the Arctic, and we find that 12% of all of the wetlands are currently protected. About 8% of the peatlands are protected. So a lot of these Arctic peatlands and wetlands, they are actually quite pristine. So in the sense of a peatland, we're talking about peatland restoration and degradation. Most of these peatlands are still pristine. But with that said, there are a lot of regions in the Arctic where that is not true. So, for instance, in the Nordic countries, in parts of Russia, there is quite a lot of peatland drainage that has happened. So, the statement that Arctic peatlands are largely pristine is more relevant to large parts of the Canadian Arctic and the Siberian Arctic. So there are big differences, but we do also perhaps see a need for more protection of these peatlands. But one thing that is, that you can't. So I'm going back again. This map shows you where we have nature reserves or national parks protecting the peatlands from drainage or people driving over them with tracked vehicles that damages the tundra. But it doesn't protect. You can't. A reservation doesn't protect the peatland from climate change. Obviously, that's a very global problem and a very global feedback. So that is something that we also looked at in this paper where we did the peatland maps. We projected global warming into the future in different scenarios, and then modeled with a relatively simple model the loss of permafrost in peatlands. And you see this map on the left shows you where you will lose peatland permafrost for different degrees of global warming. The graph on the right shows you how many million square kilometers of permafrost peatlands we have in the world, going from 0 global warming, where we think we had roughly 2 million square kilometers. Now we're a little bit above 1. We have roughly 1.5, and then you see going down in the really high warming scenarios, it's all gone, right? But you also note that around between 0 and 2 degrees, the curve is pretty steep, which means that there's a very big difference in how much permafrost we lose in the beginning, with between 1.5 degrees or 2 degrees, etc. Which is a really strong case to try to limit warming as rapidly as possible, because it also limits the feedbacks from the systems. Because as these peatlands thaw, they will start to emit a lot of methane. This graph here illustrates a very simple model that we developed of how permafrost thaw affects the greenhouse gas balance of a peatland. It starts with stable permafrost on the far left, and then goes to slowly deepening of the active layer, so how much the permafrost thaws every summer, to a collapse where you get a lake or a wet fen, and then you actually have regrowth of the permafrost. No, not of the permafrost, but of the peat again as climate warms. And the arrows show if it's a sink, neutral, or a source. So you go from having stable permafrost, that's a CO2 sink, and basically neutral for methane and nitrous oxide. And then you start emitting CO2 and nitrous oxide as the permafrost thaws. And in the thermochar stage, the collapse stage, when the permafrost is completely gone, you get a really strong methane source. And if we upscale this for the whole Arctic, we see that estimated greenhouse gas emissions from permafrost thaw from peatlands only. This doesn't include all of the other permafrost, which is also going to be affected and also emit carbon or CO2 or methane. This is just the peatlands. That at the peak, it might add as much as 2 to 3% of present-day human emissions, roughly equivalent to a third of the damage or the climate forcing we have from drainage and fire impacts. So this is, permafrost thaw is going to be a smaller impact than the human drainage globally, but it's still going to be enough to actually have northern peatlands switch from a sink to a source for several hundred years. So even if humans did not do any other disturbance to peatlands, northern peatlands would switch from a sink to a greenhouse gas source for several hundred years just from permafrost thaw alone. And we are almost committed to this warming unless we change this, or to these event scenarios if we don't change emissions or curtail emissions rapidly. So my conclusions and summary. This is really small now, I see. I hope you can read it. So our maps show that peatlands cover 3.7 million square kilometers and store more than 400 petagrams. Numbers are in agreement with the independent national inventories, which is really good. We find that Arctic peatlands are about 50 to 60% of the global coverage of peatlands. 8% of them are protected, and most are pristine, but there is also areas with substantial drainage or human damage in some regions, especially in Russia and Scandinavia. And based on earlier literature, human peatland drainage and fires are 6% of human emissions at present. This is globally. And in a warmer world, the peatlands will actually largely remain a carbon sink, but very strong emissions of methane, which has a very high greenhouse gas potential, will cause a transition to a net warming from peatlands for several centuries. And this permafrost thaw can add anything from 1 up to 3% of current human emissions, and 1% is like if we limit warming now, which is most likely not going to happen. And this is mainly from methane. And just some outlook on future work should really try to integrate human disturbances into maps. This would also let us make better comparisons between our bottom-up estimates. We assume that peatlands emit a certain amount of greenhouse gases, but what we actually want to do is to measure in the atmosphere dynamically over different peatland areas and see if what comes to the atmosphere really matches our bottom-up scaling. We know from global CO2 and global methane data sort of mapping exercises that the bottom-up scaling and top-down scaling actually rarely agrees, indicating that we still have a ways to go to really get a very solid estimate of how much peatlands are really emitting. And I think that a new generation of maps should really become at a spatial resolution where you can map individual peatland complexes, saying over there's a peatland, here there's not. Right now we just have general maps showing the percentage of peatland over large areas. We need to do better. We need to know that's a peatland, that's not a peatland, and we also need to know roughly what type of peatland it is, because that will make a big difference under warming scenarios, and also know whether it has been drained or not, because we also need to know that. So that's what we really need to sort of move the science forward. Okay, sorry, I have one more slide. I also want to do a teaser for a session on Arctic Council policy recommendations relating to Arctic wetlands and peatlands, which is linked to the maps that I showed you that we released now. So there's a session here tomorrow at 4:30 where we will sort of present these policy recommendations that were adopted by all of the Arctic countries in the ministerial meeting in May of this year. Okay, thank you. Then I will hand over to the next speaker. I think we will do questions at the end of the session, if I understood correctly. Yeah.
Thank you so much, Gustaf. That was absolutely fantastic first talk. And I think now we're moving straight on to our next talk, which is from Angela from the University of Exeter. Thank you.
Oh. Hi, so my name is Angela Gallego-Sala. I'm from University of Exeter. And I'm going to talk to you a little bit about some of the work I do on both Arctic peatlands and peatlands in the UK. Arctic peatlands, I work mainly on pristine peatlands rather than on restoration projects. And then I'll talk to you a little bit about restoration projects in the UK. So I'm going to first introduce the idea of how how peatlands accumulate carbon, and some very basic results from a prior project that then sparked the interest on looking in more detail at Arctic peatlands. And then I'll talk to you about these restoration projects that we have in the southwest of England. Gustaf has already talked to us about how much carbon there is in northern peatlands. Overall, in the whole of the world, I think I have a pointer. Oh no. Peatlands store around 600 petagrams of carbon. That is a third of all of the soil. And this estimate has been suggested to be even larger, but a very recent paper. But overall, basically, they are a very slow carbon sink, an important carbon sink over millennia, but a slow carbon sink. And they are already likely a source overall in the whole world due to degradation of mainly some northern peatlands in Europe especially, and in the tropics. So they've already, from a small sink that has been accumulated over millennia, they've now become a small source due to anthropogenic impacts mainly. I'm going to explain something a little bit scientific for those of you not scientists in the audience. Hopefully I can explain in a very simple way. So we have peatlands that have a layer of vegetation growing on top, and then the soils are below. If you imagine Gustaf's photographs of the peatlands he showed, most peatlands are wet, some are dry, but in any case, if they're not wet, they are frozen, and therefore the process in the soils are also slowed down. But you have, unlike in mineral soils where the plants are growing, the leaves fall every year and then they degrade in the soil, and that carbon is released back into the atmosphere. In peatlands, we have a situation where the plants grow each year, they die, and that plant material remains in the soil, either because it's very wet and that water doesn't allow the oxygen to come in, the oxygen that is needed for respiration of that carbon back, or because it's frozen and therefore the processes are very slowed down as well. So we have an imbalance in the carbon that comes in and comes out, and therefore we have an accumulation each year. And we have these meters and meters of peat that Gustaf was showing, where you can actually stand next to it and the peatland is higher than you. So you have this massive accumulation of carbon because there is an imbalance between the carbon that comes in and comes out. Now, my interest, so Gustaf has been talking to us about, where are peatlands now, how much carbon they store. We actually don't have answers to those questions yet, like Gustaf was explaining. But my interest is, how will the carbon change in the future? Not just where is it now, but how will it change in the future? How will climate change and anthropogenic activities impact this carbon that has taken millennia to accumulate? So it's basically fossil carbon, very old carbon. So if carbon accumulation is the result of the carbon that comes in, so the photosynthetic carbon, photosynthesis, plant carbon, and the decomposition that goes on in the soil, I'm interested to know how climate change will affect these two terms. And if you think about the first one, the plant growth, let's say, as you warm the planet, did you remember that Gustaf showed the distribution of peatlands was mainly at high latitudes, between 60 and 70. Those latitudes are limited by temperature. So the plants can only grow in a small amount of time during the year. It's a small growing season. What we call the growing season length is small. So when you warm, that growing season length will expand. And so you'll have more photosynthesis. So more carbon coming into the system. Now, that's that term, that first term. The second term is soil decomposition. What will happen when you warm? The bugs in the soil will be happier. All chemical reactions, including biological reactions, increase with temperature. This is an experiment I did during my PhD. This is the methanogens in the peatland in a piece of peat producing methane. And this is how it changes as you warm that piece of peat. So it changes, you can see, exponentially. So we expect an exponential relationship with that increase in temperature. So we expect a lot of the carbon to be released from that soil as you warm. But those two terms, both of them, are increasing. So the question, the million-pound question is, which one will increase more so that, will we have more carbon accumulated because there is more plant growth, or less because we have more soil decomposition? So we've been looking at peatlands all over the world for a long time now, trying to find out what is the answer to this question. And I apologize that you can't actually see it's because my stupid computer is a Mac and this is a PC. Sorry about that. Anyway, we've been looking at data all over the world to try and answer this question. If you look at the paleo record of carbon accumulation, the paleo record suggests, this is not a paleo record yet, I'm not talking about what's in the slide yet, but if you look at the paleo record, so how much carbon has been accumulated over time, it looks like warmer periods increase carbon accumulation in northern peatlands. And when you look, this is data from northern peatlands, so from the peatlands that Gustaf has been talking about. And this is photosynthetic active radiation. Basically, this is from colder to warmer climates, so from more northern to more southern climates. So this is how much carbon is accumulated in peatlands from the south on the end towards, from the north on the very end and the left side to the south on the right-hand side. So basically what we see is actually an increase in the carbon accumulation with increased growing season. This is how much radiation the peatland receives, just in case, but it's linked to growing season as well. So basically what this suggests is as the climate warms, those peatlands that Gustaf is talking about may actually accumulate more carbon rather than less carbon. So we have this conundrum. On one hand, we know that they will release a lot of methane, but on the other hand, we think they may actually absorb more carbon. Okay, so the project that I'm gonna talk to you about very, very briefly is an ongoing project. Unfortunately, had to be put on hold during COVID because we couldn't do any field work. But we did go to Svalbard. Here is all of us going to Svalbard with the polar bear there. It's not true, it's not true. And basically, it's a NERC-funded project, so funded by the UK government, and it's basically trying to find out if the high latitude peatlands will really be a carbon bomb. So will we see a release of carbon from these peatlands, or a stronger carbon sink? So our sites are, as I said, in Svalbard, that's European Arctic one. In actually that point should be moved a little bit. In Lapland, European Arctic 2, and then in the Canadian Arctic that hopefully will do the work this summer. And we want to look not just, so the carbon accumulation is sort of vertical accumulation of carbon, but we also want to see how the peatland extent changes as well. So the lateral expansion or shrinkage of peatlands. And what the idea is that all biomes are tending to shift northwards on the northern hemisphere, southwards, I should say polewards, and peatlands will do the same. So we will see a shift of the peatland biome northwards, and we want to see if that is the case. Can we detect that these peatlands are expanding towards the north? So we are going to these high Arctic places in search of peatlands, and I'll show you what we are doing. This is a little video. I don't know if I can play it. Can I play it? Can I play the video? No, I cannot play the video. Never mind. I wanted to show you how they look like, but you can see a little bit here on the background. So the Arctic environment, this is high Arctic, is very barren with small plants growing. And then you have these very green areas where there is kind of proto-peatlands. They're not really peatlands. You remember the definition that Gustaf gave us of the peatlands? You need 40 centimeters. They don't have 40 centimeters. So they cannot be classed as peatlands, but they are proto-peatlands, what we think will become a peatland. And what we are doing, this is a video again, I cannot show it. What we are doing is looking at the paleo record. So we are taking cores, basically. Let's say this is a proto-peatland. This is a peatland that has maybe 11 meters from end to end, and we take a core every meter, and we then look to see how old is it? Has it been expanding? So we just look at the bottom of the peat to see if we can see a basal date that is younger as you get towards the edges. That means the peatland is expanding outwards. So we are looking both at the carbon accumulation vertically and at the expansion laterally with observations on the ground. But at the same time, like Gustaf, we're also using satellite products to try and see whether these peatlands are really expanding. But there are loads of challenges. I actually want to talk to Gustaf a little bit more about this. There are lots of challenges in mapping, where the peatlands are now And, we then want to use also the satellite products that have been available for the last 30 years, let's say, to see if there has been a change in these 30 years. Can we detect a change? Can we detect that expansion northwards that we think might be happening? So that's that project. I cannot show you any results. We don't have results yet, but maybe next time. And I just wanted to put this into context that, since we are talking about climate change and nature-based climate solutions, there's been a relatively recent paper. It seems recent because the global pandemic seems to have put time on hold, that suggests that actually peatlands in the north have the potential to incorporate still a lot of carbon. So if we keep them pristine, if we don't drain them, they still have the potential to continue to grow and to continue to accumulate carbon like they've been doing for the last 10,000 years. So actually, they are very important ecosystems in terms, they suggest second only to the oceans in terms of helping us with climate change. I just wanted to move a little bit further south. So I've talked to you a little bit about the Arctic, and now I'm going to bring you down a little towards temperate peatlands. So peatlands here in the UK. I work in Exeter University, and we are surrounded by peatland areas, upland peatlands. And I've been very lucky because I've been involved in restoration projects in the southwest of England. But I just want to put that into context. So the same way that we think Arctic peatlands may be expanding northwards, we also think that those peatlands at the southern end of the distribution might be also becoming slightly outside their normal climatic envelope. So they may be more, let's say, more affected by climate change. So there is actually a paper, also relatively recent, that suggests actually this is just, let's say this is the paleo record again in a peatland. So the peatland, we're very lucky with peatlands because they hold a record of past conditions, and we can see whether it was wetter or drier in the past looking at tested amoeba. This looks at tested amoeba and European peatlands. And you can see here is Britain and Ireland. The red arrow shows where drying happens. So anything that goes below zero is suggested like it's drying. And then anything that goes above zero is wetting. And you can see mostly European peatlands are drying. And this is a combination of both climate and anthropogenic pressures. And remember what Gustaf was saying, when a peatland dries, then you have a lot of CO2 emissions going back into the atmosphere very fast, much faster than when it took to accumulate. So these slides that I'm presenting are not mine. They're Morag Angus slides from Southwest Water. But I've been working with her for a while now, actually, on restoration projects in the Southwest. And there is a large partnership. You can see the extent of restoration. There is a large partnership of loads of private, like Southwest Water, but also non-governmental, things like University of Exeter and Plymouth. It's not in there, but it's also part of the partnership. Yes, it's there, Plymouth. Government, like the Environment Agency, but also farmers and landowners. And this consortium has been in charge of restoration of peatlands in the Southwest. The objective in general is to have a holistic approach to restoration. So not just do the restoration, but also do things like education, communication to especially landowners and stakeholders. And this is what takes the longest. So the restoration projects, I'm sure that when we hear about the Scottish examples, will be similar. The restoration may happen in a few months. You may restore a large area, but to get there, to get the machines on the pit, to get that pit restored, it takes years of communication and discussions with everybody involved to agree what's the best way and so on. The pictures are not coming out. Okay, yes. So these are some pictures on the southwest. You may not be very familiar with pictures of peatlands, but these peatlands are pretty impacted. I was going to say knackered. Let's say impacted. They're very impacted. They're in many cases a kind of monoculture of Molinia, very sad landscapes in some ways. And so there is and it's due to mainly drainage, peat cutting, historical peat cutting, burning, overgrazing, even bombing, nitrogen deposition, and climate change on top of all of that. So we know, well, it's been measured that we are losing peat in the southwest at an average of 1.5 centimeters a year. That is quite a lot of carbon overall. And you can see the gullies and the desiccation, erosion, and so on. And here, the desert of peatlands is basically that what I was talking to you about. It's basically like a unique species, one species that dominates because these sites are so drained and dry. The funding up to now has been 3.5 million. I'm sure that's very small compared to the funding available in Scotland, but the area is also a lot smaller. But just to put it into context, I like this slide. How much do we value nature? We are able to pay 342 million for a piece of art, and we think 3.5 million is expensive to restore our peatlands. Maybe, we need to think about our values and where are our priorities. And this is some of the plans. I mean, I'm sure, the next talk will talk more in depth about how we do the restoration, but basically is ditch blocking. In the southwest, is mainly ditch blocking. I have some experiments involving regeneration with sphagnum plugs. So we plant sphagnum in the hope of helping the peatland regenerate faster. But I must say that it hasn't been very successful so far with all of the droughts that we have had. But you can see here the kind of timeline. It may take 5 years of consultation for then 1 to 4 months work in the ground. I just wanted to say that finish up with this slide saying that really the future of the world's peatland, like Gustaf was saying, is very much in our hands. What we do about climate change and what we do about managing our peatlands, will really make a big impact on the fate of these systems. And that's it.
Thank you so much, Angela. And I think now we're going to be moving on to our third and final speaker, which is Ben from the Scottish Government. Thank you.
Good afternoon, everybody. Can you hear me okay? Yeah, it's all good. Thank you very much. Very pleased to be here to join this discussion this afternoon in the cryosphere, and some really useful hooks for what I'm going to talk about from the previous two speakers. So you've set me up nicely. I'm pleased to say. My name is Ben Dipper. I'm head of Peatlands and Land Quality Unit in the Scottish Government here in Scotland, based in Edinburgh. So I suppose on behalf of the Scottish Government, welcome to Scotland. My role in Scotland is all things peat. So my team in Scottish Government looks after every aspect of peat, from protection through peatland restoration, which I'll talk about a bit today, through to management and all the work that we do to control other impacts on peat. So my talk, I apologize, I have no slides to look at, so you'll have to look at me instead. And I'm going to not talk about the science. I'm going to talk about the sort of dirty world of the policy and practice and delivery of peatland restoration, and in particular what we're doing in Scotland. So all the science takes place here, and essentially this is bringing it down. What are we doing with that science to turn it into action on the ground? I was really struck by all the maps of the global scale for peat there, with across the Arctic, and in many of them there was a hotspot on Scotland, either a big circle or a bit of red. And that, to me, was an eye-opener, really, about how important Scotland's peatlands are in this small corner of the world. But a lot of similarities in some ways between the peatlands that the previous speakers have been talking about. So in Scotland, we do have a lot of peat. We've got over 2 million hectares of the stuff in one form or another, which is about 30% of Scotland's land area. So a significant portion of our country is covered in peat of one type or another. It's a key part of our landscape and of our culture and our natural heritage, and it's sort of woven into our national identity here in Scotland. So we recognise the whole range of co-benefits that peatlands deliver for our environment and our communities. They are a classic nature-based solution, as the other speakers have said, to the twin crises we recognise of climate change and the loss of biodiversity, which obviously affects Scotland as well as anywhere else in the world. I won't labour the points, so we're all familiar with the role of peatlands in adaptation and resilience, so increasing the resilience of ecosystems and biodiversity to respond and adapt to the impacts of climate change, as well as actually supporting biodiversity themselves. The role of peatlands in natural flood risk management and protecting communities from flood risks in a changing climate. The role of peatlands in improving and maintaining water quality, and the role of peatlands in offering opportunities for amenity and recreation, and outdoor pursuits and mental and physical well-being, which in this global pandemic we're all too aware of the importance of. So a huge range of benefits that come from peatlands in that regard, but also obviously mitigation. And I won't speak too much about the carbon roles of peatlands, which the previous two speakers have talked about in detail. But essentially, the peatlands in Scotland, it's been estimated they store an amount of carbon that's equivalent to about 140 years' worth of Scotland's total annual greenhouse gas emissions. So there's a significant quantity of carbon locked up in peatlands in Scotland. However, as previous speakers have also alluded to, we haven't been kind to our peatlands in Scotland as elsewhere in the world. So they've been extensively damaged by drainage, by extraction, by burning and grazing, by developments such as renewable energy schemes. So we obviously have some big policy tensions there in terms of our response to climate change and what we're doing to mitigate that and contribute to tackling that challenge. But indeed, as Angela said, by climate change itself impacting peatlands in various ways. So Scotland's had its fair share of these pressures, and it's estimated that around 3/4 of Scotland's peatlands are now degraded to some degree, which is quite a challenge and quite an impact for us to deal with. So in that condition, we do start to lose all these benefits that they can provide. And as other speakers have said, as they dry and they degrade, even here in wet Scotland, they do start to emit carbon, CO2 and methane in particular. Of course, not all peatlands in Scotland are emitting, but the overall net picture is that we're getting net emissions from Scotland's peatlands. The UK government this year included emissions from peatlands in its greenhouse gas inventory for the first time. And this change has increased the estimate of Scottish emissions by about 7.7 megatons CO2 equivalent. So a massive jump in Scotland's emissions as a result of including emissions from peatlands in the UK inventory. Now, that's a big challenge for us. And Scotland's peatlands are now responsible for around 10% of Scotland's annual gross emissions. So this really sets the context for why we're doing peatland restoration in Scotland. The focus and the purpose of our work to restore peatlands is really to reduce emissions as part of our journey to net zero. Traditionally, as other speakers have said, the viewers of peatlands as being stores and places where carbon is sequestered and captured. But actually the reality for us in Scotland in a policy sense is that we need to focus on restoring them and repairing them as best we can to reduce emissions. So there's a huge challenge, but also huge potential there. And Scottish Government really sees the role of peatland restoration and the opportunities that can provide, not only in reducing emissions and supporting our green recovery and just transition to net zero through the creation of good green skilled jobs in peatland restoration, for example, and supporting rural communities, landowners and land managers, farmers and crofters right across Scotland. So Scotland's government has really put peatland restoration at the heart of its plans to deal with climate change and at the heart of its climate change plan. Now, in Scotland, we've been working hard to restore our peatlands over a number of years. Since 2012, we've put around 30,000 hectares of our damaged peatlands on the road to recovery. Now, that's a good start, but we need to do so much more. So to support our ambition, at the start of 2020, the Scottish Government committed to invest over £250 million to restore at least 250,000 hectares of degraded peatlands in Scotland by 2030. So that's our current target. It's not enough to buy your painting, Angela, but it's still a fairly significant commitment from the public purse. At the moment, we're doing around 6,000 hectares a year in terms of peatland restoration. But really, to meet the targets in our climate change plan, we need to be up at 20,000 hectares a year plus. So we have a huge mountain to climb with our partners across the public, the private and the third sectors to deliver peatland restoration at the rate and the scale we need to get to where we need to be. So to try and realise that, we're working hard on a number of fronts in Scottish Government policy and working very closely with partners right across Scotland to understand how to tackle the barriers that are stopping us reaching the 20,000 hectares a year plus restoration rate from where we are at the moment. And I'll just comment on a few of the sort of the main chunks of these fronts where we're working. So a whole range of issues around process. So this isn't as wow as some of the science, but this, as I say, is the nitty gritty of actually spending money and getting work done on the ground out in the field. And working in partnerships. Your slide, Angela, with a huge range of partners is classic. It's a challenge that we face in actually doing peatland restoration on the ground. How do you get such a lot of partners working together efficiently and effectively and quickly? And how do you remove the blockages to what's holding them back, basically, from moving forward at scale? So there's things you can do to address the processes and remove those blockages, and we're certainly working to do that. A whole range of challenges around funding. So not just the amount, I already mentioned the public commitment, Scottish Government's commitment to peatland restoration, but the type of funding. So a key barrier for us in Scotland, and it'll be the same elsewhere, is multi-year funding, so that the private sector has confidence to invest in machinery and in people. The private sector knows it's going to recoup investment in people and machinery over the years and actually build the delivery capability of that sector. So the private contractor sector is limited at the moment in Scotland, and that's probably one of the main reasons we're stuck at around 6,000 hectares a year. We need to grow that, and to grow that, we need to give the private sector confidence, and part of the solution to that is to commit to multi-year funding from government, and we've done that. So in our infrastructure investment plan at the start of 2021, we set out a 5-year capital multi-year funding package for peatland restoration. And our hope is that in time that will start to build that confidence in the private sector to invest in the plant and the people that we need to deliver. And our hope is that they will increasingly come forward with multi-year landscape scale restoration projects. So again, contractors can see a pipeline of work on the horizon and will think, right, I'm going to invest in some expensive machinery, I'm going to invest in some new staff because I'm going to get a bit of that work, and we can start to build the thing. But we're at an early stage yet. Peatland restoration is quite a new sector, certainly in Scotland, so we're building from a low base. The public commitments in terms of finance is significant, as I've said, but we also recognise that is nowhere near enough to do the whole job. There's around about a £9 billion gap in investment in Scotland's peatlands in total, from where we are now with what we need. And to fill that gap, we really need to bring in the private sector. So, it's been really interesting to hear some of the big announcements coming from COP26 this week about banks investing in green technology. And I certainly hope that peatland restoration is seen as one of those nature-based sort of technologies that will benefit from some of that commitment in future years. We need to widen the working window. So at the moment, it's quite curtailed. So the working window sort of starts when ground nesting birds finish breeding in sort of late summer in Scotland, in the uplands, and normally ends when the weather closes in, which is a bit undefined, but normally sort of late November, December, it's starting to get too wet, too snowy, too cold, where a lot of our peatland work is taking place. So it's a very limited window, and we're working with Nature Scot, which is the government agency for nature in Scotland here, to look at how we can perhaps widen that window by taking, for example, a risk-based approach to ground nesting birds. So on a site-by-site basis, can we stretch that a little bit to give our contractors a bit more time to get in? And we're also thinking hard in wider government policy around agricultural support post-2024 about the part that peatlands play in new agricultural support mechanisms going forward. So if you're a landowner and thinking, right, will I do peatland restoration? What's in it if I change my land from farming to peat? Where's my income going to come from? At the moment, you get money for farming cows, for example. What support mechanisms can government put in place to farm peat instead? So it's a key part of what's going to change hearts and minds going forward. So a lot of processy challenges. I'll just touch on some technical challenges and sort of a bit on the science. So a lot of peatland restoration we do in Scotland at the moment is sort of opportunistic, sort of voluntary. It's landowner led, so it relies on the landowner coming forward and saying, "Yep, I want to do some peatland restoration on my land." But there's a sense that to meet the targets we've got in our climate change plan and the envelopes that we've got for peatlands, we need to have a much more focused, targeted approach to this. And there's a big issue around the fact that not all peatland restoration is equal in terms of the emissions saved. So if you restore a hectare of extensive grassland, for example, so that was peatland, but it's been turned into grass to, as I say, grow cows for grazing, for example, you restore that back to peatland, you get around 10 times the emission savings per hectare on that type of land as if you restore an area of degraded upland peatlands like you were talking about, Angela. So the big question for us in Scotland is where should we focus our efforts and our investment to maximise the emissions that we can save per hectare in order to meet our emissions targets overall? Where can we achieve the biggest bang for our buck or deliver the most with the least? So bringing a spatial element into that, which links to comments you both made about mapping, the challenges of mapping and understanding where our peatlands are and what their condition is. That's a big analytical challenge for us in Scotland, but one we're working on right now with our partners across government, but also in our research institutes in Scotland and elsewhere. And we have another angle I will talk about is just a lot of focus on the carbon benefits of peatland, but obviously they bring other benefits as well, biodiversity and so on. At the moment, we're just focusing in on where we can sort of maximize the emissions that we save. But what we need to do is to think, how can we also deliver maximally for biodiversity? So where are the sites that offer us the best savings in terms of carbon emissions, but also for biodiversity? And perhaps we choose this site over that site because it offers the same in terms of carbon, but there's more biodiversity gains here, or this site here could help reduce downstream flood risk much better than this site here. So we're trying to layer up all these different criteria that we want our peatlands to deliver and see which bits of Scotland shine through as the places where we should focus our effort and our investment going forward. And to allow us to do that, there's a lot of other policy areas that have to fall into place. So agriculture is key land use in Scotland, and agriculture policy is also in a state of change and flux. So lining up all these moving parts is a big policy challenge, but it's work that's underway in Scottish Government for sure. A final comment I'd make, just and you touched on it at the end, Angela, in your talk, was around people and the need to bring people with you on our journey in peatland restoration. Absolutely agree with that, and constantly reminded of the need to take communities with us as we change the way Scotland will look in terms of the way land is used over the coming years. New initiatives in Scotland. There's an initiative called the Regional Land Use Partnerships Arrangement, which is about conversations with communities on a regional scale across Scotland about the uses they want to see in their area on a kind of regional scale for the way Scotland's land is used. And we anticipate peatland restoration and peatlands being just one of the many types of land uses that communities may well want to see going forward. And that will be a string to our bow in terms of where we do peatland restoration. If it's welcomed by communities locally, that's got to be a good thing. But absolutely agree, that's a key part. And in Scotland, it's a part of our just transition. So that's a phrase you'll hear from Scottish ministers if you hear them speaking about this. Peatland restoration is part of our just transition to net zero. So it's about maximising and allowing the investment that we're making in peatland restoration to flow out and reach rural communities right across Scotland to enjoy the benefits of our investment while helping to tackle climate change and biodiversity losses. So really, I'll call a halt there because I'm conscious of time, and there may well be time for questions. I've talked a lot about restoration. I could talk about, and I'm happy to pick up separately afterwards if you wish, about work we're doing on tackling damage to peatlands, for example, through extraction for horticulture. We made some commitments, Scottish Government made some commitments in the election in Scotland earlier this year it strengthened commitments it previously made to phase out the use of peat in horticulture in the election this year by committing to a sales ban on peat-related gardening products. So there's a whole range of policy around taking peat out of horticulture. At the same time, also bringing forward other policy to modernise approaches to deer management. Deer in high numbers can have a significant impact on the condition of peatlands. And muirburn, which is a Scottish phrase for peat burning, which is practiced quite widely across Scotland. Again, new controls on that coming forward. So on a whole range of fronts in Scottish Government, we're taking action to try and protect and restore peatlands, which, as I've said, are fully recognised as one of the main tools we have in our toolbox to tackle climate change and the loss of biodiversity. I'll also give a very quick plug to a couple of events that Scottish Government is running in the next couple of days. tomorrow morning, my Minister for Environment and Land Reform, Mary McCallan, will be speaking at an event in the Peatland Pavilion in the far corner of the Blue Zone. A talk entitled Generation Peat. We'll have a panel of speakers talking about probably in more detail about how we do peatland restoration in Scotland, some of the techniques, some of the issues around working with partners, but also speakers talking about finance and how we increase the flow of private finance into peatland restoration and some of the scientific aspects and mapping challenges, tying all that together. On Friday afternoon, just next door in the Nordic Pavilion, we have another event about wetland conservation, restoration and management from Scotland to the Arctic. That's at 2:00. So do come and join that if you've an interest. And then Friday, the last day of COP, back in the Peatland Pavilion, we have an event on peatland rights and cultures. So about the place of peatlands in all things cultural, 1:30 till 3:00. I've got some flyers in my bag which list all the details of these talks. So do ask me for one afterwards if you want to have some more details, and I'll leave it there. Thank you very much.
Thank you so much to all three of our speakers. That was a fantastic set of talks. I think we have a very little bit of time, just maybe for one or two very quick questions. Do we have any that have come in from? No, we don't. Does anybody here have a question? Do we have? Oh, yeah, we have one here. Would you like to come up and speak into the microphone?
Well, thanks so much for really fascinating presentations. I wanted to ask about something I think you're touching on is the capacity for peat as a carbon drawdown approach, plugging drainage, flooding areas, perhaps even promoting deposition of plant materials or carbon-rich runoff. Is there any real capacity? Well, I think the capacity is there. I'd like to hear your thoughts on really scaling up purposeful efforts to draw down atmospheric carbon by purposefully generating wetlands and hypoxic kind of bogs and so on. Try to, in a kind of a geoengineering approach, if you will, to trap as much atmospheric carbon as possible in the ground.
Yeah, so I can comment on that. I think that I would not view peat. I mean, I think we're mainly targeting areas that were peatlands that have been degraded, and we are now restoring them. Just because the peatlands they were growing in the places where the topography was good for peat growth. So it makes more sense to target the degraded peatlands and restore them. So I would not actually call it the geoengineering approach. I would really call it the restoration approach. And then I guess you could, in theory, also start trying to build peatlands in areas where there have never been peatlands by really massive interventions with the landscape. But I'm not aware of any major research or sort of directions taken in that direction. I think there are enough damaged and drained peatlands that we, for now, I think most science and most policy is focusing on just restoring the peatlands that were already damaged.
I'll just add one thing. So peatland extending is mainly controlled by climate. They exist wherever you have sufficient rain, let's say, or precipitation in some form to keep them wet. So if you wanted to geoengineer new peatlands where they don't exist, you would need to maintain that soil moisture, high soil moisture. So like Gustaf was saying, this is hard. It's probably it means massive interventions, but maybe not needed because we have, really extensive areas where the peatlands have been degraded, and we are still degrading them. So we are still degrading peatlands to plant, palm oil, so we are still degrading peatlands. So I think the low-hanging fruit is not on geoengineering; it's on stopping the degradation. And these, large projects, large investments that will restore large areas of peatlands. All of the European peatlands are really degraded. You know, we've been degrading them for the last 200, 300 years. These are where the peatlands naturally are because climatically, this is where the soil is wet. You know, you don't need to do anything. They're already wet. So I think this is where most of the efforts are being focused, really. I don't know if that answers the question.
Yeah, fully agree. You've clearly outlined there are existing areas where the hydrology supports that. Yeah, that does make sense. And then I think the last speaker Ben probably got into it. What fraction of the national, the NDCs could that supply for Scotland, for example? Can Scotland meet, what fraction of its carbon emissions reductions could be met that way?
Yeah, just to add, I mean, as I said in my talk, at the moment, Scotland's emissions from peatlands are around 10% of our total. So if we were to restore the whole area of degraded peatlands in Scotland, which is about 1.8 million hectares, in theory, you could stop that contribution from peatlands. But you know, as I said, we're doing 6,000 hectares a year at the moment in Scotland. We've got a target of 20,000 hectares a year. It's going to take a while to do 1.8 million hectares, and to do that, we need to deal with all the issues I talked about delivery capability and capacity. So contractors and investment. That private investment is critical. You know, there's 9 billion. Public finances haven't got 9 billion to spend on this, and it's important that the private sector plays its role, and that will start to unpack and to deliver at scale. But the point I made as well about doing peatland restoration in specific areas where per hectare you can have a disproportionate saving. So if you really focus in on areas that deliver the maximum emissions abatement per hectare as areas to target, you'll take big chunks out of those emissions from peatlands to get towards where we need to be. And peatlands is obviously within the land use change and forestry sector. It's just one part of the overall package. So we don't need to tackle Scotland's entire emissions through peatlands, but peatlands need to do their bit and reduce emissions from that are coming from peatlands. So I'm happy to pick it up afterwards if you want. Yeah.
Thank you for the discussion. I think we do need to wrap up now, but thank you all so much for joining us. And our next event, I think, will be starting in just 10 minutes time. Thank you.